All right, let's go ahead and start going through these problems. Number one, this is what we've been working on for the last 2 days. What are we supposed to do between those two fractions? What's it telling us? What operation? Subtraction. And what do I have to have in order to be able to subtract two fractions?
Common denominator.
Common denominator. So I have x plus 2, and then I have x squared minus 3x minus 10. Factoring. This guy right here we need to factor. Am I going to be allowed to use my shortcut on this?
Yes.
Okay, so then just right off to the side here, I'm going to do my x. I need two numbers that multiply to what?
Negative 10.
Negative 10, but add to?
Negative 3.
What two numbers will do that? Negative 5, positive 2. All right, so I'm going to bring my work over here because I don't have a lot of room to work down. So that first fraction was x plus 2 over x plus 2, and then minus 2x plus 4 over, and then we factor this. What's it going to look like down on the bottom here? X minus 5 and x plus 2. Nice work. So what do I need to do to get my common denominator?
Drag x minus 5 to the other side.
I'm going to drag it, kicking and screaming, to the other side. Multiply it both to the top and the bottom. So I'm going to write down, I know what my common denominator is going to be. What will my common denominator be? X minus 5, x plus 2. And then I'm going to have x minus 5 times x plus 2. And then what am I subtracting? Because I'm going to go ahead and write the other numerator down.
Minus 2x plus 4.
Minus, and then this whole thing, 2x plus 4. I'm subtracting that entire numerator, not just the 2x. So I'm going to have to make sure to distribute that so that I subtract both of the pieces that are over there. So I know this is going to need to distribute. That's not the only place where I need to use distributive property. Where else am I going to need to use distributive property?
X minus 5 on x plus 2.
X minus 5 and x plus 2. We're going to have to use some double distribution there. X from my first factor gets distributed to both pieces. So I'm going to end up with x squared plus 2x. I'm going to have to distribute the minus 5 to both pieces also. So I have minus 5x minus 10. And then don't forget we have to distribute that negative sign from the subtraction. So minus 2x minus 4. Before I go any further in the problem, I want to make sure that everybody understands why it's minus 4 there. Because that's the piece that gets missed a lot. Do you guys understand why I have a minus 4 on the end and not a plus 4?
You cross multiplied the minus to the plus.
We distributed. We used our distributive property there with the subtraction because the 4 was part of the numerator and I was subtracting that fraction over there. So I have to subtract everything in the numerator, which means I'll have to distribute that minus there. All right. Do we have any like terms that I'm going to need to combine together? Yes. We've got a plus 2x here, a minus 5x, and then we have a minus 2x right here. All three of those pieces get combined. Excuse me. Yep, and then the negative 10 and the negative 4. So we're going to have this and this. X squared doesn't have anything that it's combining with. What do I get when I combine the 2x minus 5x minus 2x? Negative 5x, so minus 5x. When I put the minus 10 and the minus 4 together, I get what? Negative 14 all over x minus 5x plus 2. Am I done?
No.
Why not?
Use an exponent.
There is an exponent up on top. We're going to check to see if this reduces. We always reduce our fractions at the end, and this is no different. The way I check to see if it reduces, I have to factor everything and see if anybody will cancel out. Just like when we're doing it with fractions, I see if I can divide the top and bottom by the same thing, because that would cancel out. So I'm going to try to factor this numerator over here. I would be allowed to use my shortcut because a is 1. Negative 14 is what I need things to multiply to, and negative 5 is what I need it to add to.
Negative 7 and 2.
Negative 7 and 2. We do have those numbers. So my numerator is going to factor to be x minus 7 and x plus 2 all over x minus 5x plus 2. Will this reduce? Yes. So what would my final fully reduced answer be?
X minus 7 over x minus 5.
Yes, x minus 7 over x minus 5. We're not so much learning new things right now in this unit. We're taking old skills from elementary school and we're learning how to apply them to things that you guys have spent the last 2 years learning about, the algebra stuff, the polynomials. All right, number 2, no algebra there, straight up elementary school. What operations are going on in number 2? Division and multiplication. All right, so let's look at part A first. How do I multiply two fractions together? Just straight across. The thing that you're remembering is called cross-multiplying, and honestly, because it's so hard to remember when you can and when you can't do it, I don't use it at all. I find another way of achieving the same end result, because I get confused too. Like, do I go like this? Do I go like this? So in my class, if you see two fractions and we're multiplying, we're always looking straight across. But I'm glad you pointed that out, because that is something that comes up every year. So when I multiply this straight across, what's my numerator going to be? 1. And my denominator? 6. And because I'm lazy, and because I also know that this looks gross on my calculator, I'm going to leave it like that right there. Are we multiplying in part B? What do we have going on there? Division. How do you divide fractions?
Well, it's a half.
It is a half.
And you have a whole number on the other side.
Mm-hmm. This is not the same thing as saying what is half of 8. Because half of 8 would be 8 times 1/2. I'm doing 8 divided by 1/2. Whenever we have a fraction that comes after a division sign, we're going to change this to be multiplication. We are going to multiply by the reciprocal. Does anybody remember what that word reciprocal means? Flip our fraction. Yes. So I recopy the first number exactly as I see it. Yep. This is going to turn into multiplication here. And I'm going to take this fraction and flip it over. What do I get when I flip it over? 2 over 1. What's a better way of writing 2 over 1? Just 2. So what this question is really asking me is, what is 8 times 2? 16. Let's practice that again. Part C, I've got 2 fractions here. I've got a 3/4 and a 1/3, and I've got what in between them? Division. So we are going to change to multiplication. What are we going to be multiplying by? What's going to flip? Do they both flip? They don't both flip. No?
The second one.
Thank you. Only the second one. Multiply by reciprocal of the second fraction. Only the one that comes after the division sign. The first thing you just copy and bring down. So 3 over 4. Change this to be multiplication, and what will my reciprocal be then? 3 over 1.
AKA 3.
AKA 3. I'm going to leave this one as a fraction, though. The last time I simplified it to be a whole number, but because my first number is a fraction, I'm going to leave this one as a fraction so that it's easier for me to multiply straight across. So I'm going to multiply these 2 numbers together and these 2 numbers together. So what am I going to get when I do that? 9 over 4.
2.25.
2.25. You are correct. And that I will accept as a decimal, although fraction form means you don't have to grab your calculators, so you can just leave it like that as well. Last one, part D. How do I do this? Multiply straight across. Okay, so I have 4 times 1 and 5 times 8. Good. What am I going to get when I multiply this straight across?
4 over 40.
4 over 40.
Or 1/10.
Or 1/10, because what do you notice about both of these? Yeah. They have a common factor. That numerator is 4 times 1, the denominator. I got there by doing 5 times 8, but I know I can also write it as 4 times 10. And then I can see those common factors just like we had on the first part. I see that the 4s are going to cancel, and so my final answer would be 1/10. Nice work. Good job. This skill down here on the bottom, this is what we're going to be practicing doing today with our rational functions. We are going to multiply and divide with rational expressions. So go ahead and flip forward in your books. We're going to go to page 181 first. This is like literally the only example problem from actual Agile Mind stuff that I use. I like that it's got these 2 side by side because it's going to use skills from what we just did in our bell work. And I'm going to compare and contrast that to how I do it with these rational expressions. So instead of just grabbing my calculator, because I know this thing is probably going to reduce in the end, I'm going to see if there's another way that I can write some of these ideas. So I've got 4 over 5. I'm going to leave that one that way for right now. Times 25. What do you multiply together to get 25? 5 and 5. So this is 5 times 5 right here. How could I rewrite 28? 7 times 4. And we just talked on the bell work that when I multiply fractions, we multiply straight across. So this is 4 times 5 times 5 in my numerator, and 5 times 7 times 4 in my denominator. Now, I realize I could grab my calculator and times it all together. But I'm wanting to point something out. Because after I do this multiplying, we always have to check to see if it reduces, right? If I leave it written like this, I can see the things that are going to cancel out a whole lot easier. Do you guys see anything that's the same between the top and the bottom that's going to cancel?
4 and 5.
The 4s will cancel.
And only 2 of the 3 5s.
2 of the 3 5s, one from the top and one from the bottom. So what would that leave me with?
5 7s.
5 7ths. Not only did I multiply it, but I reduced it pretty much at the same time.
And if you want the big numbers, 100 over 140.
You said 100 over 140?
Yep.
But then I would have to break that one down, right?
Yeah.
And so I'd end up having to go right here. So you can do that, but it's kind of an extra step. All right, so like I said, I want to compare and contrast that to how we're going to do the problem over here on the right. I'm going to leave that first fraction as is because I can't factor any piece of it. We're multiplying, and now I'm going to look at this one. Do you guys remember how we took 25 and wrote it as 5 times 5? We wrote it as its factors. I'm going to do the exact same thing here. Can I factor this?
No, it's a difference of 2 squares.
It is a difference of 2 squares. Yes, I was waiting for somebody to say it. Difference of 2, yes, 2 perfect squares. I just never have enough room to write the perfect part, but yes. So what's it going to look like when I factor the difference of 2 squares? Yep, x plus, x minus, x plus what?
2.
2.
Oh, yes, the square root.
Yep, we want to do the square root, because remember, whatever I have back here, I'm going to multiply by whatever's over here. So I need 2 things that are the same so that when I times them together, I get that number that I started with. X plus 2, x minus 2. Now I'm going to come down to the denominator, because this we wrote as its factors also. Yep, thank you. You might need to sharpen it, but there you go. You're welcome. When we go to factor something, we always look for what? GCF. Does this denominator have a GCF? X. It has a GCF of x.
So factor, that's not a difference of 2 squares.
It is not a difference of 2 squares. The reason it's not a difference of 2 squares is because A, my second term has an x with it.
And C doesn't exist.
C doesn't exist, but also what's in between them?
Plus.
A plus. It can't be a difference of 2 squares if it has a plus. So that's a great point to bring up. What am I going to have inside these parentheses? X plus 2. We multiply straight across, so I'm going to write it as one single fraction, and I'm going to see what cancels. So I have x times x plus 2, yep, times x minus 2. Down on the bottom, we had an x minus 2, and then I have an x and an x plus 2. What's going to reduce here?
The x and x minus 2.
Yep. The x and the x are going to cancel. X plus 2 and x plus 2. Anything else?
Yeah, x minus 2.
So is my answer 0?
That means it's not valid.
What's 5 divided by 5? 1. What's 4 divided by 4?
1.
1. If I multiply something by 1, it stays the same, right? If I multiply something by 1, it stays the same. So if I do x divided by x, what do I get? 1. What about x plus 2 divided by x plus 2? 1. X minus 2 divided by x minus 2? 1. So how does this whole thing simplify? 1. If everything cancels, it simplifies to just 1. That's true if everything in my numerator cancels, but I still have stuff in my denominator. My numerator would be a 1. Anytime I have a side of a fraction where there's nothing left because everything canceled, there's still a 1 there. All right, let's do a couple more that are like this second problem. You're going to have to flip forward to page 184. Page 184. All right, so off to the side, I'm going to write out our steps here. First thing, if it's division, if it's multiplication, I skip this step. If it's division, you're going to flip which one, the first or second fraction? Second. If division, flip second fraction. Then we're going to factor. And then we will cancel. All right. Do I need to flip on this problem? No. No flipping. Cool. So then I factor. I've got a bunch of things to factor. Let's start with the numerator. Can I use my shortcut on the numerator?
Yes.
Thank you, sweet Jesus. I need two numbers that multiply to give me what?
-3,
And add to?
2,
What two numbers will do that?
a headache.
What two numbers will, well, let's start with just like, what multiplies to 3? Yeah, 3 and 2 are the only things that multiply to 3 that I know of. Or sorry, 3 and 1. You guys said 3 and 1, and I looked up at the board and I saw the 3 and the 2, and out of my mouth came the wrong thing. What'd you say? -3, +1?
3, -1.
Wait, no.
Yeah. What's my b value? 2. Is it positive or negative? That means the bigger number has to be positive. If b is positive, the bigger number has to be positive. If b is negative, the bigger number has to be negative. Okay, so 3 and -1. So that numerator is going to factor to be x plus 3, x minus 1. Let's go factor that denominator next. Can I use my shortcut on the denominator?
Yes.
Yes. I really like it when that works out. It makes my work so much faster because I don't have to draw all the boxes. I can just draw some x's. Needs to multiply to what?
16,
16 and add to?
8.
8.
They're both 4.
They're both 4. 4 plus 4 gives me 8. 4 times 4 gives me 16. So I have x plus 4 and then another x plus 4. We're multiplying this. Does this numerator factor? Yes. What can I take out? 3. So let's take that GCF of 3 out. What would I have remaining if I take the GCF out? X plus 4. Does the denominator of the second fraction factor at all? No. No GCFs, no x squareds. Means it doesn't factor. We multiply our fractions by going straight across. So I'm not going to write this as one fraction because that just seems like an extra step. I know that I could just drag that fraction bar over. Anything going to cancel?
Yes.
Yep. X minus 1 will cancel with x minus 1.
And x plus 4 with the x plus 4.
X plus 4 with x plus 4. So let's write down what we've got left over then. What do I still have in the numerator? Yep, x plus 3 and 3. Normally, if we have just a number or a single piece, something that's not inside parentheses, we'll move it up to the front.
Yes.
Yeah. Because remember, when it comes to multiplication, it doesn't matter the order that I write them down in. Like 7 times 4, 4 times 7, I can switch them around. What do I have remaining in my denominator? X plus 4. Can it reduce any more than that? No, I'm done. I am done. You can if you want to, but you are not required to. So the question was, don't you have to distribute the 3 up in the numerator? If you want to, you can. I'm not requiring you to do that. Because what I really want to see when you're done with these problems is that it definitely doesn't reduce anymore. And so if you leave it all factored out like this, both you and I can see that it doesn't reduce anymore and that it's fully reduced. Does that make sense? Okay. This is as hard as it gets. Really. This is as hard as this gets, and we're going to take today and tomorrow to practice these ideas. Let's go look at B. I'm going to write my steps down again. Do I need to worry about the first step?
Yes.
Yes. Why?
Because
Because it's
it's division.
division. So before I do any factoring, before I draw any x's, what's this going to look like?
It's going to be the first row when the first fraction, then the second one flipped.
Yep, leave the first one alone. Just recopy it. And then we're going to flip this second fraction. And when we flip it, it's not division anymore.
Oh, yeah.
Once we flip it, it's not division anymore. 2x squared minus 7x plus 3 comes up to the top. Oh, and thank goodness they did some of the factoring for us. Because what do you notice about all the other
What's all
remaining pieces?
You can use this one.
Yeah, 2 of them we can't use the shortcut on. Third one we can, but we still have to factor it. We still have to do the work.
Yeah.
All right, so let's look at the first numerator here. I'm looking at this guy. Let's do our x. I need 2 numbers that multiply to give me what?
2,
And add to
3,
3. What multiplies to 2 and adds to 3?
2 and 1.
2 and 1. All right, I'm going to actually have to draw an area model out for this. No shortcut. So I'm going to draw my area model here. So I have A and C, 2x squared and 1. And then the 2 numbers that we found were 2 and 1. So I leave it like this.
No, put the axes on top.
Put the x's onto those pieces that we found. All right, we got to go side to side. We got to go up and down. Which way do you guys want to go first this morning?
Side to side.
Side to side. So I'm looking right here. 2x squared and 2x. What can we take out?
2.
2x. What about here? 1x and 1? 1. Positive or negative?
Positive.
Positive. There's one of my factors, so that's going to go up on top of my numerator. And now we've got to go up and down. 2x squared and 1x. 1x. 2x and 1. 1. Positive or negative? Positive. All right, you guys told me I can use my shortcut on that other denominator, right? Or on the denominator for this one. So let's do my x here. Multiplies to give me what?
Negative 15.
Negative 15. Oh, I recopied it wrong. Huh. Scoot that over, add that piece. There we go. Multiplies to give me negative 15. Adds to give me
2,
what will do that?
5, and negative 3.
5 and negative 3. Always start with what multiplies to give you the top. Don't worry about the positive or negative part. Just what numbers do you know of that multiply to give you the top. Then start playing around with your plus and minus signs. X plus 5, x minus 3. Remember, we flipped this guy over. So I have x plus 5 and x plus 1 here. And then I've got to factor this numerator, which means another box. Pick a color. Let's go with purple. I need two numbers that multiply to give me what? 6, yep. Because I have to do A times C, so I'm doing 2 times 3. Multiplies to 6, but adds to what? Negative 7. Well, let's just start with 6. What are some things that you know of that multiply to 6? 2 and 3. Well, if I make both of them negative, will that add to negative 7? No. What else multiplies to 6?
1 and 6.
1 and 6. If I add 1 and 6, I get 7. So how would I get to negative 7?
Just put a negative sign on both.
Put negatives on both of them.
Negative 1 times negative 6 is positive 6.
That's absolutely correct. Negative 1 times negative 6 gives me positive 6. All right, draw my area model. Put my A here and my C here. So 2x squared and 3, negative 1x, negative 6x. We went side to side first last time, so let's go up and down first this time. What can I take out of both 2x squared and negative 6x? 2x. What about negative 1 and 3? Negative 1. So 2x minus 1 goes up here. And now we go side to side. 2x squared and negative 1x. X is the only thing I can take out. Negative 6x and a positive 3. Negative 3. So x minus 3. I know that multiplication just goes straight across. So in my mind, I just kind of like drag this fraction bar over. Is there anything that's going to cancel or reduce? X plus 1s, that's the first thing I heard. There's an x plus 1 here and an x plus 1 here.
X minus 3.
X minus 3. Yes, nice to point that out. So if you guys couldn't hear, what Jayon said is, in order to cancel out, you have to have 1 on the top and 1 on the bottom. So these two will not cancel. Five divided by 5 cancels out to 1. But 1 over 5 times 5, that does not equal 1. That's why they're not canceling. So to be done, I'm just going to write down what I've got left over. What do we still have in our numerator then? 2x plus 1 and 2x minus 1. That reminds me of a difference of 2 squares, huh? What do we have down in the bottom? X plus 5 Just once?
Twice.
Twice, so I have to write it down both times. That would be my final answer.
Can you just write 2x plus 1 squared over x plus 1?
Good question. So if I was going to simplify this, well, not necessarily simplify this. If I was going to write this in another form that means the same thing, I could double distribute in my numerator. That means I have to multiply these first two pieces together. What's 2x times 2x? 4x squared. What's 1 times negative 1? And that's what it would look like. Because that's a difference of two squares, right?
Yeah.
X plus 5 times another x plus 5. Well, how would we write 5 times 5? What's a better way of writing that? 25. Or I could write it as 5 squared, right? When I take something and multiply it by itself, so I could write this as x plus 5 whole thing squared. I'm totally fine if you leave it like this. Would that also be correct?
Yeah.
Yes, and so I'd accept that for full credit. All right, we're going to keep practicing with these tomorrow. We got 4 more problems down on the bottom of the page. That's what we're going to finish up tomorrow. Homework 1 was due this morning. If you didn't do homework 1, the adding and subtracting, please go in and do that. Homework 2 will be due on Friday. That's the multiplying and dividing. You might see some adding and subtracting thrown in there for review. So pay attention to what operation you see in between the fractions. Right? And I think I deserve a gold star. I finished before the warning bell today. I never do that.